Hey, everybody. Fascinating chat today around the world of AI, data, and innovation, and what's next in this space with an innovator and thought leader from Keymakr. Dennis, how are you?
Hi, Evan. We're doing very nice. Thank you for having me today.
Well, thanks for being here and really intrigued by this topic. Before that, maybe introduce yourself and
Yeah,
what's the
sure.
big idea, the mission behind Keymakr?
So my name is Denis, and I'm a head of project management in Keymakr. And what are we exactly doing in a nutshell, let's say? We are working on the data in terms of curating it to our customer needs or creating the data if, let's say, the data is not there on the market. So we're basically providing human eyes, human hands, human approach to train computer vision. So we're those eyes that will guide the machine vision.
So that's interesting. Why do we need eyes? I thought the whole idea of AI was, you don't need human input, but why is annotation so important when it comes to the success of AI models?
Well, I would say you would always need human eyes to extent, depending on, let's say, what type of precision in your industry is currently required. Let's say if you have a drone, I don't know, let's say flying around a tomato field, right? Or I guess tomatoes in a warehouse or whatever. Let's say a tomato field, and it will recognize with 95% precision that this tomato is ripe and this one will say is rotten. It's not a big deal. But if your autonomous vehicle is driving and it needs 99 plus, close to 100% precision to identify if this is a pedestrian, if this is a green light or a red light, and so forth. Imagine, I don't know, let's say any medical domain where you will do a operation or remote operation and so forth. So in some industries, for now, we're fighting or helping companies to fight with this particle of a percent of preciseness where it's truly needed. So it's one of the examples.
Interesting. So yeah, let's take automotive. That's a fascinating space right now with robo taxis from Waymo and Elon Musk and many others. What is the state of the industry, state of play, let's say, and how is it going? What's next to really reach the full
Um,
potential here?
It's a great question, and I can actually even continue with what I've just left off. So, in the automotive, I would say one of the biggest challenges or the areas that needs attention is active safety. Well, let's say we all started with, let's say, cars basically recognizing lanes, right? Then cars were recognizing, let's say, animals crossing the roads. Then it was pedestrian. Then, let's say, motorists, people on the bikes, and so forth. But now it's more about being active or even say proactive. So the car would not just stare ahead, but it would also analyze what might happen. Let's say there is a sensor inside of the vehicle saying it will overlook the gaze of your eyes, your, let's say, what are you doing? Maybe you're lighting up a cigarette, or you're playing, or you're distracted with the phone, or you're staring in the rear view sorry, not a window, mirror for a while, right? Or putting a makeup or something else. So therefore, the car would be able to tell that something is definitely going on, something might happen, and together with the car or vehicle overseeing with all types of sensor, LiDARs, radars, and so forth, combining all this together, it might say that, hey, something is possible. So let me start braking or whatever the algorithm is. So the car or the vehicle, let's say not only the car, will try to analyze and be proactive. So what I think this is one of the most challenging areas that we're working on for now, because pretty much every vehicle can say this is a stoplight, this is a deer running across of you. So it's pretty easy. But being proactive for active safety, that's the key for now.
Interesting. So I have real questions for you here about self-driving cars in Boston. If you ever
Mhm.
driven in Boston, we have ice, we have snow, we have the craziest, most aggressive drivers in the country. extreme conditions, really, how would, annotation and continuous model improvement, let's say in an area like Boston, work?
It's a great question, and it's good that you mentioned, let's say, Boston or the US or a particular weather conditions. Because let's say your the model, right, that you put in your vehicle to be so is for it to be self-driving, it might completely work, let's say, in a perfect weather condition, right? It's sunny, there is no snow, it's not slippery, the car is rolling, all is good. So this is why, and this is why a company like us are on the market, because you might need to train your model with particular sets of, let's say, requirements or conditions, such as how does snow look like visually? How does melted snow look like? How blizzard looks like? How does, let's say, the lane, right, or whatever markings or the pavements are, how they look when they're covered with snow, and so forth. So, as mentioned earlier, you do need to train your data basically for, let's say, different countries. We had a customer that we used to work on the data sets from US, from Europe, from Japan, from South Korea, because the everything, like the environment is too different. So it might work in US, but it will work less or not work at all, let's say, in Japan or in the UK, where everything is basically left-handed, right? Um, right.
Yeah,
I believe
great
I
point, great
answered.
insight. And let's talk technology specifically. There's a big war on the pros and cons of LiDAR versus radar versus camera. And, each company in this space has different or differing, competing in some cases, approaches. What's your take on the different pros and cons of these technologies?
Well, for now, well, I'll briefly give you an insight of, what is the con and pro of each and every one. So basically, it's all down to effectiveness and, in fact, if in its work and its economic effectiveness, right? So let's say you can put a LiDAR, right, which is basically a radar that is using laser beams, right? So it will be very accurate, let's say, to measure the distance, right? It will not really be affected by lighting conditions, right? So if it's day or night, doesn't really matter. On the other side, it's pretty short ranged, right? So LiDAR, let's say, again, in a basic way, let's say driving around your neighborhood, your LiDAR will be very nice on a sunny day. But if you're doing 100 miles on a highway with the cars being like, I don't know, let's say half a mile or something is in front of you, it will not really reach those. And this is where radar will kick in, being cheaper, but being a more long range, let's say. So LiDAR is definitely there, is doing a good job for the range finding, depth measuring. But again, it's pretty expensive. It really requires a lot of computational power. And if we talk about automotive industry, it really has limited performance in some bad weather. Not even bad weather, but let's say even some rain or fog can really interfere with it. So just a LiDAR will not fix it. Radar or just camera, again, they're cheap, they're nice, they're everywhere. It's really affordable. It's good to capture all types of objects, but it might have harder time in terms of precision. So the camera or radar, it might have pretty low resolution, right? When radar is seeing an object, it's something that is moving in front of you. So you cannot really tell if it's a motorcycle or a person on a bicycle, right? And depending if what types of vehicle this is, it might be moving slower or faster. So I would say, to summarize, for now, the real industry trend is the sensor fusion. So you don't really choose either one, like let's say radar or a camera or a LiDAR or something. It's really best if you combine all of them together. And this is what, again, we're not to mention brands of those vehicles, but or the cars manufacturers, but let's say the biggest one, the fanciest one, they're actually combining all of those three, at least maybe more, together for the most redundancy and robustness. So sensor fusion is the future.
Interesting. And what about data creation for different vehicles? I mean, obviously you have sedans and SUVs and trucks and other SUVs. How does that differ per vehicle?
You're saying, refine your question. You're saying, how is data creation working for different types of car bodies, let's say?
Yeah.
Well, to specify data creation, if we talk about data creation, it really is, let's say, a niche product. When you're working on your model, right, and doesn't really matter what kind of industry you are, if it's automotive, agriculture, medical, I don't know, retail, security, logistics, whichever, you really need data to work on, right? Where can you get the data? You can crawl internet, right? You can just collect it, right? Let's say you work on the face recognition, you can just crop some YouTube videos. You can download some Instagram pictures or some Facebook pictures or whatever, but you not always can find the data with a specific scenario. So let's say if we talk about automotive, and you are training your model to be able to recognize and distinguish all different types of car bodies or vehicles, right? You would need, and this is something that we do, you would need, or you might want to create the data for yourself. Now, when we talk about data creation, and it's a huge topic, it's like, basically we can call it Hollywood for computer vision. You can take the data basically by creating it, actually making a movie with your pre-required um, conditions, or you can create synthetic data. But synthetic data, and we will talk about this later on, I believe, in our interview, synthetic data might not really cover all of your scenarios. To make it shorter and easier, let's say you need 10 minutes of videos where a person, let's say I will describe myself, a Caucasian male, I don't know, let's say late 30s, wearing a cap, lighting up a cigarette, holding a phone in his hand, and turning steering wheel. You cannot really find open source data to train your model. So this is something that you would want to create. And when you create the data, you need diversity. So we'll have people of different genders, nationalities, skin tones, and so forth. So data creation is there when you need to have your data set tailored to your particular needs. Yeah, it's a big question. Sorry, so I can talk for hours here.
No, I'm sure we only have a few minutes, but are there some, major drawbacks with synthetic data? It seems to be a hot topic, or is it, like you said, fusion of you want synthetic data and real world data, real world annotation?
It really depends. I believe when you just start your the training of your model, right? Let's say you just want to teach your vehicle to be able to distinguish when there is some obstacle. So you can totally open, well, again, let's say whatever data creation module, right? You can use AI software to just generate whatever you want. And for the basic needs, it would be enough. But if we talk about, let's say, some really delicate and precise autonomous vehicle driving, you really need more tailored scenarios. Like I mentioned earlier, let's say you have a busy street, it's snowy, you have a school bus in front of you, you have, yeah, it's winter, but you have guys on motorcycles passing you by, right? And this you can totally create a synthetic data for it, but synthetic data would not really help you that much because you really need live person behavior. So short answer, or to summarize, when you're just starting on your AI training, synthetic data can totally help you. But again, it works. Let's say sooner or later, you would need some real data that you can either collect, that we can do for you, or create. Again, based on your script, your requirements, whatever your data scientist will tell you. So synthetic data is there, but it's not one-stop shop solution, let's say.
Interesting. And maybe for us, describe at Keymakr the end-to-end process from, new project creation to deployment. What does that look like, and what are some of the barriers that you have to overcome, and some of the best practices you have to deploy in a typical engagement with a client?
It's a great question. So we can take, I can answer this in example of two types of project, like let's say just annotations and data creation. So let's say in scenario one, you would give us, I don't know, terabytes or hours of videos, right? Of you driving around your neighborhood, let's say. And what we would need to do is basically analyze your data based on the guidelines that you would give to us, as well as we can totally help you to tailor them. Let's say you would like to know on this particular second or frame of the video, what is the probability of a crash? Like you see a car in front of you, let's say 10 feet, you're doing 25 miles an hour, and you need a human or a team of people to tell you what is the probability of you doing a crash. Is it 25%? Is it 75%? And so forth. So one of the most challenging part is us to look at something subjective and agree on or to have a consensus. In other words, the most difficult part is, let's say if you look at my sweater, you need to have about, let's say 10 people, 20 people, 100 people saying that this is particularly navy blue color. How are you going to achieve it? Not black, not dark blue, not light navy blue, whatever. This is navy blue color, right? This car is exactly 10 feet off you, and it's like 70 to 85% probability of a crash. So we're training our people to have or eliminate this subjectivity. So that's number one. We will take your guidelines. We will work with you in iterations, like a basic any IT project will work. We will deliver data in small batches, make sure that it fits your needs. We will receive feedback because, in training the data, it's really important to do alterations all the time. It's not that you start on January 1st and then we'll see you in 6 months later and here's your annotations. No, you would constantly give us feedback as your model will evolve. So we're basically working iterations. Working on documentation, iterations, receiving feedback, applying feedback, deployment. Roughly, this is how we work with data annotation projects. And data creation, which I called earlier like a Hollywood of AI, well, that will take, I believe, a couple hours to cover. But basically, yes, it's like you're making a movie. So I'll ask you, what do you want? What is the script? What do you want to see? What is the length? What are the props? What is the lighting conditions? Which hardware should we use? What should be the resolution? So imagine it's like you're making a movie with exactly the same process. Well, maybe it will just be shorter in time. But basically, it's like a Hollywood for AI.
Fantastic. What a great opportunity. So any big predictions on some breakthroughs we might see over this year and next? Do you think we'll see success with true self-driving, level 5 autonomous driving? Will we see Elon Musk robo taxi finally be realized? What's your prediction in some of these areas?
Well, again, it's we're all human, right? So as mentioned earlier, we have subjectivity. So I personally think that it's already here, it's just not scaled up yet. So the robo taxis are there. The let's say the Gen 5 of autonomous vehicles is not there, but it's about connectivity, right? So sooner or later, cars will not just be, let's say, analyzing what is in front of them, how to avoid it. This is what they're doing now. Cars already, as mentioned earlier, are proactively analyzing you as a driver. Are you tired? Maybe even there is a thermal sensors, right? Maybe having a fever. So basically, there is proactive safety. And pretty soon, I would say, the cars, the autonomous vehicles, I keep saying cars all the time, but it's not exactly correct. It's better to say vehicles. They will be basically communicating to each other saying, hey, I am approaching this intersection. I'm approaching this intersection. Okay, let's make sure we don't crash. So long story short, it's coming. How quick? Again, depending on the technology, I believe in terms of documentation, legislation is there. They have a green light. So it's coming. I would say a year or two, maybe less. And another, I would say, addition that I think is coming next is AI being able to work with different data sources. So let's say you can have a camera, right? Looking at if we talk about vehicles, you can have a camera looking at the road conditions and trying to predict something. It can recognize the text, right, on the road signs. But what we're really lacking, and is just starting to evolve, is the AI model that will understand and combine different data sources, text, images, videos, 3D data, audio data, sensor data, combine all this together and provide you a solution. So this is a next step, I would say. Some companies work on annotating images, and other companies work on annotating audio, and other work on sensor data like thermal, infrared, so forth. But combining all this together is the next step. It's a very small step. It's coming. We're talking months, years, maybe, but pretty soon.
Wow. On that very exciting and positive note, thanks so much for sharing those insights. I couldn't be more excited about the future of autonomy and autonomous driving. It's just incredible time to be alive, right? So thanks so much, Denis, and
Exactly.
good luck on the journey. Take care.
Thank you, Ivan,
And
and have
thanks,
a good
everyone.
day.
Thanks for listening
Bye-bye.
and watching and sharing.
Have a good one.